Okay, this video is about 4.1 imaginary and complex numbers. We're going to skip this part with the song. Pure imaginary numbers for any positive number, b, there exists a square root of a negative value of that squared, coming out to be the square root of the perfect squared times the square root of negative 1. The square root of negative 1 is the imaginary part, so this is represented by I. Complex numbers, we will talk about here in a minute, but each part has a real number and a pure imaginary part for which are not like terms and cannot be added. It's in the form of a plus bi, and where a is the real number and bi is the pure imaginary part. Square root property, we can use that to take the square root of both sides when we're solving. If there's a square root of a negative number, we will have an I in the answer. You can isolate variables into the conjugates, where we'll do two complex numbers in the form of a plus bi or a minus bi. We're going to use this to simplify, so you will use the opposite of those. So the way that the powers of I work is, what are we doing? So I is really the square root of negative 1, and each part is simplified out. So I equals the square root of negative 1, which equals I squared equals the squaring of this value, which comes out to equal negative 1. I cubed equals I squared times I, which gives me negative 1i, which equals negative I. The fourth equals I squared times I squared, which equals negative 1 times negative 1, which equals 1. So the way it works out is multiples of 4, so every fourth multiple is going to equal 1. So down here, this is really I to the fourth times I equals I to the fourth times I squared equals I to the fourth times I cubed equals I to the fourth times I to the fourth equals I to the fourth times I to the fourth times I. So you get a repeated pattern. So what's really cool is if you take the exponent divided by 4, that's going to give you an answer, 1.25. So 0.25 is 1/4, or 0.25 equals I. If you get 0.5, that equals I squared, which equals negative 1. You get 0.75, that equals I cubed, which equals negative I. And if you get any number that ends in 0.0, that's I to the fourth, which equals 1. And I do it quickly that way instead of converting over, because 0.25 is 1/4, 0.5 is 2/4, which is I squared. This is 3/4, which is I cubed. 0 is 4 divided by 4. It's a perfect even distribution, or division, sorry, which equals out to be I. So once I do this and I memorize this, that's what I do to simplify. So the next page, we're going to just simplify. So let's go here. Square root of negative 81 is really the square root of negative 1 times the square root of 81. It's the positive root, but when you add the square root is when you do plus or minus. If we don't add it, it's just going to be the positive. So this would be 9i. This becomes, because I is square root of negative 1, square root of negative 1 times the square root of 32. This is I. This is going to be times the square root of 16, 2, which is 4 square roots of 2. So you get 4i square roots 2. Coming here to the next one. Before you do any multiplication, you need to simplify first. So you have 3i square root of 24, because I'm going to pull out the negative, times 2i square root of 18. So when we multiply these together, we get 6i squared, square root of 24 times 18. Break down 24, break down 18. This comes to simplify. I squared is negative 1, so negative 6. Breaking these down, this gives me a 4 and a 6. This gives me a 6 and a 3. So I have a perfect 6. This gives me 2 and 2. and square root of 3. So negative 6 times this is going to be negative 6 times 2 times 6 square roots of 3 gives me negative 72 square roots of 3. So, simplify this next one. 4 times negative 3 is a negative 12 times I squared, because I times I is I squared. I squared is negative 1. Negative 12 times negative 1 gives me a 12. So, here I'm going to take 40, divide it by 4. That equals out to be 10.0. That means my answer is going to be 1 because it's a multiple of 4. So, I to the 4th equals 1. 63 divided by 4 equals 15.75. So I had to have 15I to the 4th times an I cubed, 75, not 17. So I have I to the 4th 15 times I cubed, which gives me the answer of negative I. So that's the first day's lesson. Moving on for the sake of the video. Solving. So this would be using the square roots. So what I can do, I'm going to isolate x squared. So 4x squared equals negative 32. Divide by 4, divide by 4. X squared equals negative 8. Square root of both. I'm going to simplify this out. So before I start, I'm going to have I square root of 8. Because I'm going to pull out the negative. Negative is I. Break this down. This is 4 times 2. So I'm going to have 2I root 2. That's my answer. Now, since I added the square root in, it's plus or minus. This next one here, x squared equals negative 1. Take the square root of both sides. X equals plus or minus the square root of negative 1, which I should have added up here, plus or minus, there we go. Square root of negative 1 is I, so x equals plus or minus I. And that's your solution as well. Okay, simplifying. So adding, when you add or subtract complex numbers, like parts go together. So it would be negative 1 minus 2 plus 5I minus 3I. Negative 1 minus 2 is a negative 3, plus 5 minus 3 gives me a 2I. Same thing with subtraction over here. 7 minus 1 is 6. 4I minus 2I is a plus 2I. They are different terms, so this is real, this is imaginary, so they have to stay separated. It does not combine to be 8I. This next one, you're going to multiply it through. I suggest you strongly show all your work. So 6 times 9 is 54. Plus 6 times 2I is 12I. 9 times negative 8I is negative 72I. Negative 8I times 2I is a negative 16I squared. 6I squared always will change the sign of this. This is really negative 16 times negative 1. So it becomes a plus 16. I squared will always change the sign of whatever numerical value is times it. Combine these, I'm going to get negative 60I and 54. 54 and 16 combine to give me 70 minus 60I. This next part here, multiplying again, 3 times negative 2 is negative 6. 3 times 4I is plus 12I. 2I times negative 2 is a negative 4I. 2I times 4I is positive 8I squared. So simplifying combine like terms, this is going to change to a negative 8. So negative 6 minus 8. Combine these two, plus 8I. So I get negative 14 plus 8I. Last but not least, multiplying by conjugates. Conjugates, in order to get rid of square roots in the denominator, because I is the square root of negative 1, you would need to multiply by the conjugate. Conjugate is where you just take whatever numerical value is on the denominator, you write it out, in the opposite form of what you have. Now, the reason why we do this is if you look above, when we FOILed i's that were not the exact same values, we ended up with I terms, which means if we don't switch the sign, we will not cancel out our i's, which means we would still have square roots in the denominator, and we can't have square roots in the denominator. It's a special form of rationalizing. And whatever you do on the top, you must also do on the, on the bottom, you must also do on the top. So I'm going to take 3 minus I times 4 minus 2I on the top, divided by, I'm going to do the work for this one, but then I'll show you the trick off to the side. So 4 times 4 is 16. 4 times negative 2 is a negative 8I. 2 times 4 is a positive 8I. 2I times a negative 2I is a negative 4I squared. Excuse me. So, multiplying the top, simplifying the bottom at the same time. This value here is really plus 4. So I get 20 on the bottom. On the top, I'm going to simplify that over here. I'm going to get 12 minus 6I minus 4I plus 2I squared. So this really is negative 2. 12 minus 2 is 10 minus 10I. Now, each one of these is divisible by 10, so I would simplify it out. So 10 divides into 10 once, minus I divided by 2. Unless all three parts can be divisible by the same number, you do not simplify it. Okay? So here, as you saw, these values canceled out in the middle. So what you can do to be quick about it, 4 plus 2I times 4 minus 2I is you square the first, add what is on the second. So you add the squaring of pretty much negative 2. Or you add 2 times negative 2. So you add, you subtract a negative 4, which becomes a plus. So you subtract what is the second multiplication, and it always becomes an adding, because it's a difference of squares. So, next one. But the reason why it's a negative 4 here, and you're subtracting, minus plus. I'm going to have to check my math. No, I did that right. So minus the second number. Or you just put a plus sign every single time. So on this one, it would be 25 plus 6 times 6, which is 36, which gives you 51, 61. I don't like that one. I'm going to remultiply that out. So just to double check, because I know how to do it quickly, but I don't know if I'm doing it right now. So 5 plus 6i, 5 minus 6i, because this is the conjugate, is going to be 5 plus 6 minus 6i, top and bottom. This is 25. Middle numbers cancel out. This becomes negative 36i squared, which becomes plus 36. Yeah, I was right. I like it when I'm right, but I'm not sure. So 25 plus 36, multiplying the top, 2 times 5 is 10, 2 times negative 6 is negative 12i, I times 5 is plus 5i, minus 6i squared. So I get 61, 10 plus 6, because that becomes a plus 6, is 16. Minus 12i plus 5i becomes a minus 7i. And there you go. So your two assignments will be what is on your assignment sheet. And I will make sure those are posted online. There you go, your lesson for 4.4 both days.